Well, that is what we call dependable, even. However, the two Explorer tests have been going through space for 47 years at this point. Their notable exploration mission is still going all out, as is notable. The indistinguishable sister tests have now even passed the limits of the Sun-powered framework and recorded a progression of secretive revelations that leave even the most experienced cosmologists open-mouthed. However, what undram of designs truly lie lethargic in the profundities of interstellar space? And shouldn't something be said about the outrageous attractive wall that one of the two tests identified here? Well, these questions are likely as interesting as the episode that happened in October 2022. That was when Explorer 1, which had already been going in space for 45 years, was hit by the most remarkable gamma burst ever recorded. At the same time, anyway, the base power of the exhibition also exemplified an inestimable secret. The flare-up and its radiance simply didn't conform to our ongoing models, and the specialists were thus confronted with an unimaginable event. From the present perspective, it seems almost humorous when Explorer 1 and 2 dove into the tremendous region of space on August 20th and September 5th, 1977. No one thought that this was the beginning sign for one of the greatest success stories in space travel. No wonder, after all, the initially anticipated mission term was only 5 years, and the test was simply expected to gather new information about the outer planets of the nearby planet group and their moons, which had so far remained largely neglected. But after the rocket had taken the first, and sometimes novel, pictures of Jupiter, Saturn, Uranus, and Neptune, NASA decided to extend the mission and let the Explorer tests fly to the edge of the heliosphere. No problem at all with a couple of many years of waiting. While Explorer 1 arrived at the Sun's defensive magnetic bubble in 2012, its sister followed 6 years after that. Until recently, never had a man-made object infiltrated such a long way into space. In numbers, this means that the shuttles have now put an unbelievable distance of 24.8 and 20.7 billion kilometers between themselves and the Sun. On the other hand, the tests also gave Earth-based researchers a special opportunity to study the extreme edge regions of our home system at short proximity and to directly investigate how our Sun interacts with the particles and magnetic fields outside the heliosphere. However, since Explorer 1 had already arrived at this unknown world 6 years before Explorer 2, specialists were all the more eagerly awaiting the appearance of the subsequent twin test to compare the newly gathered information with the new data. And without a doubt, the examination immediately uncovered an astonishing likeness. While the specialist had previously expected that the heliosphere was deviated and had a shape that stretched far back, the data from the Explorer test suggests that we are dealing with a balanced, or in other words, round structure. Yet the contrasts in plasma that were recorded were more pronounced before entering the heliopause, i.e., the peripheral limit of the heliosphere. Explorer 1 had identified a solid rot of the plasma flows, while the section into the interstellar medium was characterized by areas of strong turbulence in the surrounding plasma. In view of this, the analysts thought a thick, but unstable, boundary region. But the case of Explorer 2 was very different. From one viewpoint, it took only a portion of a day to cross the heliopause. And, on the other hand, it was not confronted with the extreme plasmatides that its sister test had experienced. In other words, the heliopause presented itself as steady and slight this time. But what is it really made of? Well, the specialists point to the impact of the Sun, since Explorer 1 experienced the heliopause during a base in the solar activity cycle. It can be expected that interstellar magnetic fields and astronomical radiation entered further into the boundary region of the heliosphere at that time. Serious areas of strength for the movement that accompanied Explorer 2's entry, on the other hand, may have stabilized the heliopause in combination with the strong solar wind. An immense magnetic wall. Anyway, this was not the only thing that Explorer 2 should find in the edges of our home system. And where the test identified something that had already been predicted on paper, the energy among analysts was limitless, because evidently, there is without a doubt a broad magnetic wall on our side of the heliopause, which acts as an extra protective shield against vast radiation. In detail, the magnetic field in this vast boundary was stronger than any other magnetic field measured in the heliosphere to date, and it appears to be very unique in nature. Specialists say that the solar magnetic wall is made by magnetic flows moving toward the heliopause, where they eventually die down and flow sideways when the magnetic field direction of our host star switches in the next activity cycle. This process starts from the very beginning once more, but this time with opposite polarity. Up to this point, so astute. But we should not forget that we are still far from having decoded the puzzling spreads of the heliopause and interstellar space. While the Explorer data suggests that the outer regions of the nearby planet group and the interstellar medium form a complex system, we are still just at 2 places in this gigantic framework. Considering this, specialists demand that development missions are essential for a more revealing overall picture. Anyway, this is still cosmic future music. But if we glance back as of now and picture the technology with which the Explorer tests have achieved their amazing achievements, their indefatigable efforts become even more astounding, since said technology is now from the 70s. It can confidently be described as dusty, and you just have to understand that if you have a cutting-edge smartphone, you have a device with a memory capacity multiple times greater than that of the Explorer probes. Besides, the transmission data of our modern mobile phone connections is nearly multiple times higher than that of the two seasoned professionals. Anyway, the fact that even the most hearty technology from past times eventually reaches its limits is demonstrated by recent developments. While sudden contact interruptions are now part of Explorer's daily routine, NASA has been pursuing a severe power-saving strategy for quite some time that is intended to extend the test's lives. In detail, more and more parts that are not essential for the operation of the shuttle are being turned off. In the case of Explorer 2, this most recently affected the plasma sensor. Conveniently, Explorer 1 was required to keep its instruments active to measure in October 2022, so it was the first to report to researchers on Earth a critical display that caused a stir in the ranks of astronomers. The most remarkable gamma burst ever. When Explorer 1 was speeding through interstellar space, its instruments sounded the alarm. Its systems did indeed report a mysteriously large influx of high-energy radiation. And if you like, the test went about as a harbinger of an unheard-of exhibition that was to hit Earth 19 hours later. In detail, the recorded gamma radiation was so intense that almost all our observatories, including NASA's Swift and FEMI telescopes, were immediately oversaturated. It soon became clear that we were dealing with the impacts of a gamma-ray burst, unprecedented, which would hence fill a whole extraordinary release of the journal The Astrophysical Letters, respectfully named Most Brilliant Ever, or BOET for short. Furthermore, given the scientific name GRB 221009A, the record-breaking event immediately raised an essential question. What in the world had set off the extreme ejection? After all, we were dealing with an event that had an energy of 18 tera-electron volts and, subsequently, appeared multiple times brighter than any previously noticed ejection. However, that was by no means all. The ejection also produced a somewhat strange fly of radiation that pushed the current models of the radiance of such events to their limits. More specifically, the cosmologists revealed a new component in the radio spectrum of the stream that left them utterly confused. But other ranges of radiation also displayed bizarre inconsistencies. In addition to other things, the fly seemed to be unusually strong. In April 2024, cosmologists were finally able to identify the origin of the record explosion. However, the main point was that this finding only raised more questions. The radiation, which was so extreme that it even changed the Earth's ionosphere, didn't come from a huge supernova, but from an incredibly typical cosmic explosion. Essentially, this is what follow-up investigations with the James Webb Telescope's high-resolution near-infrared spectrometer showed. But how could a standard stellar death trigger an event that, according to specialists, happens on Earth only once every 10,000 years? Well, that's precisely the question. However, one that still hasn't been addressed convincingly. On a fundamental level, anyway, space experts suspect that the extreme gamma rays could be linked to a special type of explosion. When rapidly rotating massive stars collapse, they produce bundled particle jets that race through space at nearly the speed of light. And if these jets are especially thin and concentrated, they produce an exceptionally bright high-energy beam. Since the jet of the record event also had one of the tightest streams ever recorded in a gamma-ray event, researchers believe that the energy in the cosmic explosion might have been transferred in a similar manner. The background to our jets, anyway, is much less puzzling. Click the subscribe button now and stay tuned to never miss another video from us again. We'll see you soon.